Okay. So I guess we have everyone. So thank you very much, and hi Nick. I know we have you always on QGIS workshop, so it's nice to have you again. Maybe I shared a link on the chat just in case. Normally I've sent you an email last week. So we will work together today using a project ready with data and everything. So please have it download on your computer, and of course have QGIS installed. So just quickly before I start presenting a bit the context, in this folder that you may have already opened, you will have some data sets, some model. It will be kind of the correction of what we will do today. And then you have the projects. There is only one, so you can already open this project for later. This is the QGIS project we will use to create our data model, our graphical model. And finally, there is a link for documentation online that we will use a lot with Simon, and that you can use later on because we know it's 1.5 hours. It's really short. It can be dense depending on your knowledge and so on. On top of that, it's online. But if you want to continue wherever we stop at the end or not today, you can continue using the documentation actually. So feel free to scroll this documentation for later, but during right now the workshop, normally we will manage to work like kind of together step by step. And of course, if you are stuck at any time, you have any question, we can see the chat. We have Constantin with us that can help. So feel free to interact with us. We are not that much, so it's also a good opportunity for that. Okay, so to start this session, so the aim really of this first discovering of graphical modeler in QGIS is to create a first model, create a first data workflow directly in QGIS. So QGIS Graphical Modeler, I don't know if you already used it. I think it's not used a lot, actually. It's not as powerful as an ETL like FME or Talent, but it's as QGIS really available with lots of documentation. It's free. So it's it's really good to have kind of try to use it and to know what we can do with it and how we can make it useful in our project, in our way of working with the data. For people that are like have maybe more technical background, I think it's important to know that creating model, creating data workflow can also be done directly with a development language such as Python or R. So it can be really powerful. Here, the idea is more to be more accessible for people that are not used to create such workflow or that are new to spatial analysis or even to GIS. And this is really the aim of this workshop. So what we want to do today for our model. So we wanted to work on use case involving fire analysis. So what we did is extracting or using a dataset, which is a fire dataset coming from the NASA, and to work on it in Brazil. So as you may have heard, Brazil is having lots of fire and beating like records last summer or last month even. And what we want to do today is just to start with an accessible data sources of fire location and try to do some basic spatial analysis and try to calculate the density of fire by administrative area, but also by grid, and then maybe to have later an output on our workflow to create maps, for example, to have better analysis on fire location. Here we will really focusing on the model itself. The idea is really to get used to this graphical modeler of QGIS. So as I was saying, what we will do is creating our first model. So I will do that with you in a few minutes. And then with Simon, you will try to improve this model, to think about it and to think about ways to improve it, to add some more inputs, more data treatment that can be interesting to run in the model. Talking a bit more about the data itself. So the data we are using, as I was saying, is coming from the NASA, especially the films. So the fire information for resources management system. So this is something that is almost lively, providing fire location visualization and data sets. Basically, it's done by satellite imagery, so it's more like of a raster data set, but it's extracted as a vector data set. So each point is the center of a theoretical pixel where the fire is located. So as you can see on this image on the middle of the screen, if you have a grid of points, it means that it was like kind of a continuous fire over an area. For the workshop, we extracted some data. So when you are thinking about creating a model, maybe what you want to do is sometimes to use, let's say, what we can call live data, like Web Feature Service, WFS, or Web Map Service, WMS. In our case, we didn't do that because the WFS only provides the data for the last 7 days in these data sources. So we wanted a bit more than that. So we request a data set. Everyone can do that from the NASA, and then you can request for a specific country and a specific time, and then you will receive the data set. So the data we have on the project is based on an extraction that we requested as a shapefile. And before we start, if you already open the QGIS project, you will see that the layers are already loaded in the project. So all these tons of points are actually the fire location. So you will see, if you zoom in a bit, you have behind the satellite imagery, so you can easily see the relation between deforestation and the fire, because most of the fire are linked to agricultural practices also. You will have also some admin division for the country that we will use to calculate the density of the fire. And as a background, we have the satellite, Google satellite imagery. So before we start, is it clear for everyone on the context and what we aimed for today? Feel free to send questions in the chat. Oh, okay. So if you're not so used about using QGIS, maybe, I don't know if it's the first time you open the project, we won't stay in this main window. We want to go in another part of the software to open actually the graphical modeler tool. So to do that, we will go under the menu bar on the top, on the processing bar, and select the graphical modeler. So if you click on it, it will open the new window, which is the interface of the graphical modeler. So in this interface, it's pretty simple. You will have the big white part on the left, which is where we will create our model. So basically, it will be boxes that will be connected to each other. This is a way we will work. It's graphical because it's a visual model. We will only add bugs and manage the parameter of those bugs, the relation between it, and then we will run our model. So to manage what we'll have in our model, we'll have panels on the left. The one on the top are the inputs and the algorithm panel, which allows us to select inputs for our model, select algorithm to feed our model, actually. And then below, you will have another panel for the model properties. It's more to save it for later, and some history history of usage and do history. We can go back in time, and then you have all the option on the top between the menu bar and also with shortcuts with buttons to open, save, export our model. So first, what we want to do, a model is always divided, let's say, in two parts. We have first the inputs of our model. So it's what the user will have to give to the model. And then we have the workflow that is created with those inputs. So to start our model, we want to add an input. So this is the first step. So I want you to maybe take 1 minute or 2 minutes to just explore the inputs you have on the top left panel, and maybe try to search for an input that you can use to import our main input, which is the fire dataset. So I will give you 1 or 2 minutes to take a look, and do not hesitate then to, I don't know, open the mic or write in the chat if you have any suggestion. Okay, so we are doing some logistical management. So do you have any idea of which input can we choose to add our layer as an input in our model? Any idea? Okay, so can you see my screen? I have a comment that it's not shared. Can I have a validation? Okay, so no, don't see. Okay, I will share again, just in case. Okay. Okay, can you all see the screen now? Good. Okay, sorry for that. So maybe you weren't following. So to first start my model, my input will be quite easy. It will be a vector layer. So if I want to add this input to my model, I can double click on it or drag and drop this into the main area, whatever. If you do that, it will open a new window to parameter your input, actually. So please do that also on your side. So it's quite easy. Here I'm adding an input, which is a vector layer, meaning that my user, to start my model as a prerequisite, would have to select or to give a vector layer to my model to fill in. So I will add a description. The description will be useful to know what is expected here. So for example, I know here I want to give my fire dataset as an input. One option I can also put is the geometry type. It's interesting because I can constrain the geometry type depending on my workflow later. I know that here I will always work with fire dataset or equivalent, which are point vector layers. So I will select the point geometry type. I will keep this as mandatory because it's required for my model to work. So it's mandatory for my model. If you have set those options, you can click on OK, and you will see that your model is starting to be filled. So what I want you to do is to do exactly the same thing for the other input that we'll have to do our analysis. So our analysis in this first and simple model is just to try to calculate the number of fire in each administrative area. So on one point, I will have my fire. On the other point, I will have my administrative area. So I want you to add another input, this time to add the administrative area. So I will leave you like a few minutes, and if it's done on your side, you can type in the chat, or I don't know, open the mic to let us know that that it's done. And if you have any issue, just let us know. Well done, Manon. First one. Good job, Nick. So actually, we are just replicating what we just did before, just changing like one or two options, but it's kind of the same step. I will leave like 30 seconds more, and then I will do it on my side also. Okay, well done, Christophe. Okay, so if I want to do that, I can reselect again vector layer as an input. I can also copy paste in a model every boxes, so I can copy paste my inputs to duplicate it. So Control C and then Control V. And if I want to modify the parameter of this input, I will just have to double click on it. It will open my input window, and I will change, and this time I will name it accordingly to the layer I want. So it will be an admin division layer, and this time it's not a point, but it's a polygon. It's important because later in my model, my analysis will depend on the geometry type of my inputs. So it's important to put the proper geometry type. It's also mandatory, so I can leave it as it is and click on OK. So now I managed to build, let's say, the first part of a model, which are the inputs, but my model cannot run actually because I need to have a workflow. I need to use these inputs and to do something with those inputs. So what I want to do now is to use spatial analysis, an algorithm in my model, to calculate the number of fire of points in each admin division, in each polygon. Again, I will leave you like 3 minutes, 2 minutes to take a look at the algorithm you have here, and maybe try to find an algorithm that will do this, that will calculate the number of points in each polygons. And if you have any idea of the name of this, you can also put your mic on or write this in the chat. Okay, so Christophe, do you have any idea of the name of do you propose an algorithm? That's why you are mentioning, or?
Yeah.
Okay.
Yeah, I used the vectorial analysis. There is one which who can count points in polygon.
Exactly, yeah. Good job, Christophe. Yeah, exactly. So, yeah, this is why also Nick is saying. So, there are lots of sub types of folder, let's say, in the algorithm. So it's sometimes hard to find what we want. Of course, we are more in the analysis part, in the vector part, so you can search this. If you have an idea, if you know the name of the tool in QGIS, it's easy. You can search for them in the search bar. But if you don't know, you have to scroll a bit to see what's available. So indeed, what I want to use here, it's count point in polygons. So I find it by researching. And again, I can drag this and drop it in my model. And again, I will have my parameter to set to be then available in my model. So here, what's really important to understand, when you put an algorithm, you will always have to link it to layers, to an input, to know based on which vector feature it will provide the analysis. If you try to scroll, what we have here on the top, we have like first the polygons for the analysis and then the points. If you try to open the drop-down list, you will see that maybe it's not the case for you, but it's linked to a model input. You can change this option clicking on the icon on the left of this. If you select, or if something else is selected, for example, if value is selected, you won't have exactly the same proposition in the drop-down list as you had before. Because when you select value, you are selecting layer available in your project. But what we want to do is not really to link this to our project, but more to any vector layer available in our laptop. So I will select my model input as an entry for my data analysis. This way, it will be linked to my admin divisions here for the polygon for my input, and for the points, it will be linked to my Fire dataset on the left, the input on the left on my screen. Then you will have a few options linked to the tool, so you can weight the calculation. Here we won't have any field to do that, so we won't put anything. Same for the class. What we can do is maybe rename the field name for the count value, because what will happen with this algorithm is that it will create a polygon layer which will have an attribute, a column, gathering the number of fire in each features, in each polygon. So I can leave it as it is, or I can put something like fire number, something like that. If I click on OK now, you will see that I have a new box, and this box is directly related to my inputs. So visually, I can understand my model, which is starting from two inputs and feeding an algorithm that will calculate my count, my number of points in each polygon, in each admin division. So let's say that we kind of did the second part of a model. We did the workflow of data. It's a really simple one. You can do simpler than that because there is only one algorithm. But still, if I want to run this model, nothing will come out of it because I need to select an output for this model. So an output of a model is what will be, let's say, exported from the model, and usually what will then be automatically added to our QGIS project. So if I want to do that, I need to reopen my window of property of my algorithm. And I just have to enter a name in the last parameter, because if I put a name, it will automatically create an output out of it, meaning it will kind of create a new layer that will be added to my QGIS project. So I can put something like count fire in admin, something like that, just to understand. And if I click on OK now, you will see that my model is now having an output. So it's easy to understand a model because you will have the inputs in yellow, any algorithm will be in white, and then you will have your outputs in green. And as you can see on my screen, you can move everything as you want. Of course, now the model is simple, but it will be a bit more complicated later with many boxes. So it's important to try to keep it understandable for you. So did everyone manage to have the same process that I have right now on the screen? Okay. Great. So now our first model is ready. Congratulations, you did your first model. One thing we want to do now is to make it to run, to test it. So to do it, you can either select model tab and click on Run Model, or use this shortcut button on the last shortcut button on the menu, the toolbar on the top. So if you click on this, you will have a new window, this time to run the model, and you will see your inputs on the top. So my two inputs are my vector layer. So here I have a drop-down list because it's linked to my project, but I can open any other layer that I have on my laptop, on my computer. So this is why it's interesting to work with the model, for example. You don't have to load anything in your project. So I will select here to do my first test, the admin1 division of Brazil and my fire dataset. I forgot to mention that we have two fire layers because the way NASA is working on the dataset is that the last 3 months dataset is separated from the oldest data, because the last 3 months data is still data that is sometimes under assessment and evaluation before finalization. So that's why they are keeping this apart of the other. So if I want to select the latest data, the last 3 months data, I can select the one which is called Bryce Fire NRT M blah blah blah. So I see a question from Manon. To get from here, I clicked on, you can click on Model on the menu bar on the top left of the screen and on Run Model. It will open this window. Okay. So as I was saying, you will select your inputs, and then you can select a location to save your outputs if you want to have it stored in your computer. But what's interesting is that by default, it will create a temporary layer, which is good because usually we are testing our model and improving it step by step. So we don't want to save too much shapefile or a geo package in our computer. So you can leave it empty for now, and always let the option ticked in the end to open the output file after running algorithm. It means that the file, the layer will be open automatically in your QGIS project. So now let's run this. So it seems to work. My algorithm is finished. I don't have any error message, so which is good. Now, if I go back on my map visualization part of QGIS, I can see that I have a new layer, which is called Count Fire in Admin. So this is my output of my model. If I open the attribute table of this layer, I will see that I have a new column added, which is the fire number. And for each feature, for each region of Brazil, I have the number of fire that are in each polygon. So congratulations, you did your first model. You can see it's quite easy to do. Just to understand what we are doing, basically what I just did and what we took some time to do with the model is something that you can do in one click in QGIS. Actually, if I go under vector menu bar on QGIS, under analysis tools, and I use count points in polygon, I did exactly the same as selecting my layer here as input, and it will create a new polygon layer with the fire number in each polygon. It's exactly the same. Basically, the graphical modeler is using all algorithms available in QGIS, but the idea is to do some models that are a bit more complicated, because otherwise you just have to run the algorithm directly in QGIS. And that's what we will do right now. That's what you will do with Simon, is try to improve this model, to think about a way to make it more accurate, more tailored to what you want, and yeah, to have something more interesting. So if you have any more questions related to the part I just did, let me know in the chat. Otherwise, Simon will take over.
No question? So everything okay? So yeah, we go in the part to enrich our model. So we are now in the step. We have two parts to enrich our model. So the part 1 and the part 2. We will try to go more far we can, but if we cannot, what I suggest is we stop maybe 10 minutes before if we cannot go at the end. I think we cannot go at the end because it's dense, and I will explain you all the next step, and with the documentation you will be able to redo all the model for the exercise. So in this first part to enrich our model, we will work to manage data confidence of our fire dataset, and we will try to manage to have a date selection, to do calculation only on the range of date we wish, and so to focus our analysis on precise dates. And we will try also to do some calculation of density of fire. So first, before go deeper in our model and try to build it, we need to try to think how we will do, what kind of input we need, what kind of algorithm we need to build our model. So first, the best is to maybe think about the representation we want and we need. We want to represent. So we speak about fire density. So the fire density will be calculated in our Brazil state area. So we will need to have a density number for each state of Brazil. And to manage confidence, we will need to have a field which detail which level of confidence we have in our fire point layer. So to go deeper in it, we can maybe open one fire point layer, the attribute table. So it looks like this. And here we can see all the fields, all the attributes we have for this fire point layer. So we have the date the date of the fire. So for each point, we have different dates. And on the right here, we have the confidence of the point. So if it's 100, we're sure it's a huge fire burning. And if we have a low rate confidence, like 21, it's less sure. It can be errors or things like that. What you can see in the documentation, we have several levels of confidence. It's used by the specialist. This level of confidence is used by the specialists of the NASA to distinguish the different points they record. So we have the low confidence level, so 0 to 30, nominal confidence, and high confidence. Most of the web map in the web are done with high confidence level. So only the point with 80 and more confidence level. So before start to build the algorithm, as I say, we need to think what kind of attribute I need to create, what kind of field I need to create, what kind of calculation I need to do, and we need to try to plan how we will build our model, what algorithm we will use. So firstly, we will try to manage the data confidence. So we will have to define in our layer, because if we see the attribute table, so this one, we will have to say this point, so the confidence is 21, so confidence level should be low. So we need to define a new attribute, say this point is low confidence level. So we will calculate that. And we will have to count the fire point for each confidence level. So like that, we will be able to calculate density for high confidence level, nominal confidence level, and low confidence level. So for each type of confidence, we will be able to calculate density of fire in the different states of Brazil. So to do that, we will start to calculate the confidence level attribute. So to do that, here in the documentation, you have an expression you can copy paste, but first to create a new attribute, to calculate a new attribute, we'll use the algorithm field calculator, as you can see in the documentation. So if I go back to my model, here I can let the count point in polygon, the output, the right, and here I will go find the field calculator. If someone has question, or don't hesitate to go in the chat and write something, or even take the mic and interrupt me.
Documentation, yeah.
Yes. The link to the documentation. So I go back to my algorithm. So here I have the description. So the description starts by the name of the algorithm. So to be clear, because we will use many algorithms, I need to detail each algorithm, because after, when I will need to call the results of algorithm I used before, I will need to know the name of it. So for the field calculator, I will add confidence level, as we will calculate the confidence level of the model. So the input layer will be the model output too, model input too, but it won't be the admin division, but the fire dataset. So I select the fire dataset. The field name will be conf L, like in the documentation. So the best for you is to try to follow the name of the field I use, because we will reuse all this name in the different algorithm we will create. So it's important to keep consistency, to don't be blocked or something because it's miss one letter or it's write differently. So our kind of field, it's a string, so text. So I select it. I need to select the length of the field, so we don't need 100 character, but I can put 100 to be large. And here I have an expression to fill. So here, I don't know if some of you know already the field calculator algorithm, but here you have the where to create your expression in QGIS, and in the middle you have all the different function of the field calculator. So if you click on it, on the right you have the description and how to fill the different function. But you have also here in the field and value, normally you have all the field and value of your layer. But here, because we are in the generic model, it's not linked directly to a specific layer in our project. We haven't all those fields. So if we want call one of these fields, we will need to know how it's called. So we will go in the attribute table and to know how the field in the layer it's called. So I will go back on the documentation. And here in the documentation, you have a specific boxes to copy paste the right expression to calculate the confidence. So you can do Control C and Control V. So here in the expression, so it means if confidence. So this is the field of the fire dataset layer. So the field confidence. So if it's above 30 and below 80, it's nominal fire. And if it's under 30, it's low. If not, it's high. So when is that? And what I will do to be sure my expression is right, it's to create an output like that. If I run my model, I will be able to check if everything is okay, if my expression is okay. So will write confidence level. I will click on OK, and here, as you can see, I can manage to scale a bit my boxes to see what is it. And here I have my new algorithm. So if I click on run, you see here at the end they propose me the two output, configure in admin and confidence level. So I pay attention, my layers are right selected, so it's good. I click on run and I hope everything goes okay, no error message. Maybe it can be, normally not. Pay attention about, maybe you don't know about what I'm speaking. I try to answer about Manon Moreno. She said the expression wasn't right on her side. Normally it's the same language. So one code
seems to be a typo.
Okay, perfect. Good. So now I run the algorithm. I go back in my project, and here what I can see, the model creates two new temporary layers. This is the temporary sign. So I can open the confidence level output, and I will check if the calculation is right or not. So I open it. I go on the right because the new field appear on the right, and here I have the field conf L that I created. So if I select one, the confidence is 83, so it's high. For the second one, 65, it's nominal. We are in the good range. 28, it's low. It's okay. The expression works. So now I know I can continue my model. What I can do is to now I know this algorithm works well. I can just cross the output like that. It's not create anymore in the project the output when I will run the model. So I can also delete in my project all the temporary layer. Like that, I'm not lost when I redo some running of model. Oh, so I delete it, like that's a bit clean, and I go back on my model. So here, now I have the distinction of each different confidence level for my fire dataset point layer. And now I will need to calculate density, because finally it's what we want to do, calculate density for each confidence level in the different states of Brazil. So I will need to count these different point fire in the different admin states. But to do that for each confidence level, I will need two algorithms. One to select the right confidence level point, and one to count the point, only the appropriate confidence level point in this polygon. So if I go back in my documentation, here, if I go a bit down, I will have to count fire points in administrative polygon for each level. So before use the algorithm count in polygon, I will use an extract by expression to select only high fire, and after select only nominal fire, and after select only low fire. And for each, I will count point in polygon only for high fire, etc., etc. So it means I will create in the administrative layer. Maybe I can open it before for you, the attribute table. I want to create finally 3 new fields in the different states of Brazil. One for the number of points, the number of fire, of high fire, the number of nominal fire, and the number of low fire. Basically, that's all. So, as I say, I will try to firstly extract. We can start with low fire, for example. I will extract by expression here. So this one, the low fire. So here, I think to rename my algorithm to be sure understand what is it. So low fire. Here, the input layer will not be the model input because I did some calculation before. So it will algorithm output. So here, for now, I have I have 2 because I use the count point in polygon. But what I can calculate before is the field calculator confidence level. So you can see for now it's important to rename your algorithm to be able to find the results. I click on it, and here the expression will be to select only low fire point in the fire point dataset layer. So I open a double quote to select the right field. So conf L is a field I just created, and equal to 1 quote to select a value, and it's low, like that. So here we have the output for matching features and the output for non-matching features. So we let it like that, click on OK, and here we have our new algorithm, extract by expression for low fire. So we need to do the same thing for nominal and high fire. So the best way is to copy paste. So I select the box, Control C, Control V, and I even can do 2 times. And I will have just to double click. Yes.
So there's a quick question from Manon. So for you, Manon, in French, it's extraire par expression, not géométrie par expression. So extraire par expression. Let us know if you can follow up, because it slowed down a little. So let us know, Manon, if you can follow and
yes. Yes, if you have all the interface in French language or different language, it will change all the algorithm names. So yeah, it can be a bit tricky to find it. Maybe
what you should have mentioned, maybe to use English version.
Yeah,
you did not
but
think about that. Yeah.
We know the translation. Yeah, I know it, so I can tell it if needed. What we can say more, maybe before go further, it's all algorithm we have here. We have all the QGIS algorithm, but we have also algorithm from Saga, from GRASS, and GDIL. So it's other kind of algorithm, but it can be used in the model graphic modeler. So if you're friendly with grass, you can use all the different algorithms there is inside.
And to mention for people using foreign languages, it seems that if you research in English in the search bar, it will still find the algorithm, even if it's not the same exact name in your language, because it's searching for English. So,
like for example, if I put extraire.
No, I think it's only working on the other side. Like if you're in French, if your software is in French, you can search in English.
Sure.
And take a look.
No,
yeah.
Only in English. You can find for other language. So that's okay. I can continue. So what I just did before, it's to configure the extract by expression. So I call the confidence level field I created before with the field calculator in the FirePoint dataset, and I request to select only the low point fire. And after I copy paste 2 times this algorithm, so we see here, and I will rename, I will modify the 2 I copy paste, one for nominal fire and one for high fire. So nominal fire, here I change the expression to, so I just to change the value, nominal expression, what's wrong? Maybe the italic.
I think last quote, yeah, simple quote here. No?
No, me now quote. Yeah, things good. Why is double quote? Yeah, better like that. Now it works. When it's red is when it's not good. So when it's okay, so we did it for the nominal fire, so it's okay. And extend the box to add the name in the first, and we do same for the high fire. So high fire. Click OK, and here I have my 3 algorithms ready to select by confidential level. So now I will have to count point in polygon for each type of confidence level. So I have already one count in polygon, point in polygon algorithm set in the model, so I will just have to modify it to use it. After I will have to create 2 more. So here we'll start to count. So firstly the low fire. So count point in polygon for low fire. I put the description. Here in polygon it will be the input model, so that means division, because it's the first. And for the point, it won't be the fire dataset input, it will be the algorithm output. So here, if I should select the right one. So as you can see, you have all time the matching features and the non-matching features. And you have the algorithm use, so extract by expression, and you have what we add at the end, so low fire, nominal fire, or high fire. So it's really important to define a name for each algorithm. If not, it's all the same name and you are lost between them. So we start by low fire. So we need to have the matching feature from algorithm extract by expression low fire. So I select it. And here I will just have to count to define the name of the field where the number of fire will be counted. So same to keep consistency with the documentation and to not be lost in the when you work on your side or you redo the model. The best is to have the same name as the documentation, like that you can easily go back on the step. So it's work like that, and be low fire. So here we don't need output, so I can remove it for now, and I can click OK. And now you can see it will take the admin division layer and the extract by expression low fire to calculate the new field, the number of low fire. So I need to do the same thing for nominal and high fire. If I go too fast, let me know. I can re-explain things or come back on some view or something. So when I copy paste, I have to double click on the properties. Here, I change the description. So now it's for nominal fire. So here, it's we have a little change. Our polygons we will use, it's not anymore the input of the algorithm, because we already calculate polygon layer with the first count pointing polygon algorithm. So here I will change it to algorithm output, and I will select count from algorithm count point in polygon low fire. Is that okay? So here, because we are in nominal fire, I will just change low by nominal and click on OK. I see the links between algorithm. I do the same for high fire. So I copy paste. I change polygon, so it's not anymore low fire, but it's gone for nominal fire. And for the point layer, it will be same, the matching from features nominal fire, this one. Select it, and here, because it's now high fire, I haven't changed the name, so I need to change it too. If not, we will have two nominal fire. So and I change the field name in high fire. So here we are quite at the end of the step to manage the data, the confidence level of the fire dataset and admin dataset. So so I will create an output of count fire in admin. Like that, I will be able to check if our model is running right or not. everyone is able to follow? Is that okay for you? Where you stand? All good? Oh, Christophe, yes? Yeah. So, when we're ready, you can run the model. So, it's saying now we have only one output and we remove the previous one. So we select the right one and we have just to run. So run, just have to wait. Everything okay, no error message. If there is error message, here you can find or try to find where come from the error. Like all the algorithms start one by one, and all the log message details what happened. So if there is errors, you can find the way to solve it from here. So I close it, everything okay. So I can go in my QGIS project and I have my new temporary layer create, configure in admin, can open the attribute table to check. And I see on the right of the table, I have my 3 new fields. So one for low fire, one for nominal, and one for high fire for each state of Brazil. That's okay? I guess. I guess so, like Semanon. So now, in the step 2 of the part 1 to enrich our model, we'll try to manage the date to select a range of date, a range of fire points between 2 dates. So what kind of question can ask you? I lost my question.
Which inputs maybe do we need?
Yeah, which input do we need? And which input do we need to do that? And where we will put our algorithm to select the good range of date in our model. Like after which algorithm I will put my new algorithm to select the good range of date. So we have 2 questions for you. Which input and which place for the new algorithms will calculate the range of date?
So should we filter our data, the date of our data before we count the points, or after we count the points, for example? %50% of chance to guess properly, so you can try one.
No ideas? So before, yes, yeah, we will do it before, because if we do it after all this counting, it means it will calculate a huge amount of data. The computer will do many calculations for all the data, and at the end it will select only few dates and it will give you the output. So it will takes really long time to have your output. If you do the selection before of what you need, and after do the calculation will be quicker because it will be done on few points. It will be on a few points, so it will be quicker. And what kind of input we will have to add? It's the date time input, this one. So here we'll have to double click on it. We'll call it the date 2. We will use only the date. We will keep it as mandatory true. So we'll have one new input, and we will create a second input to have the date from. So it's more the inverse finally, but same. No matter in which way you put in the schema, it's same. So same, only date, not date and time, or time, only date, and as mandatory too. So OK. And here we will have to select only the fire point between these two dates. So what we will use is the extract by expression again. If I'm not mistaken, no one is that. Yes, is that. And we will use this expression. So this expression means this is the attribute field IQ date in the attribute field of the fire point level. So should be above the date from and below the date to. So I copy paste the expression. No, before I can open a new algorithm. So I can copy paste too, but I can also we do some extract by expression here. I will add date to understand what is it. The input layer will be the fire dataset because we put it at the beginning of the model. And here I can select the date, the expression. So I go back on the documentation, select all, Control C, Control V, and here I have my expression. So here I let the matching features and not matching feature like that. Click on OK, and I have my new algorithms. So what I need to do now is to link these new algorithms to the previous one. So finally, it's only this one, the field calculator of the confidence level, which I need to change the input. So it's not anymore an input of the model, it's the algorithm output, and it's selecting already matching feature from algorithm extract by expression date. So it's perfect. I have only to click on OK, and here I see the link. So one thing I need to do it's to manage dependencies between all these algorithms. To be sure, these algorithms start before the computer start to calculate these algorithms before start calculate this one. Because this one depends of this one, and this one depends of this one, and this one depends on this one. So if you start something without all the results before, it can crash. So need to pay attention for each algorithms to say which one should be calculated first. So I take the second algorithm in my way, and here in the down of the box, I have right dependencies, and I have 3 dots on the right. I click on it, and here I can select the algorithm before. So it's extract by expression date. So this is simple because there was only one before, but after, for all other, it will be more, you will have more choice. So for this one, it's the field calculator confidence level. So I select it and click on OK.
And maybe to add that this step, it's not mandatory, it's more to improve efficiency of the model, not to use too much resources. In our case, normally the model will run, even if we don't do that, but if you have like more wider or bigger model, maybe it's important to manage these dependencies to make sure that the way the process is, the way QGIS is calculating those, it's waiting for other data and not consuming data because it's calculating at the same time many processes.
So it's like it's a bit like it's a bit like the name all the algorithms, manage dependencies. If you continue to enrich a model more and more, or you share it to someone else, it will help people to understand your model. But even you, it will it will help become your model more stronger to face to the bug or things like that. So this one, we are in polygon, the first one for low fire, so it depends on this one, extract by expression low fire. Select, I click OK. OK. And for this one, so depend extract nominal fire and count point low fire. And this one, the last one, it depends extract by expression high fire and count point in polygon nominal fire. So you see, when you have dependencies, you have new kind of line which link in more the process. So we are just in time to finish. We have less than 10 minutes before finish. So what I suggest is to show you, but maybe I run this model. I haven't run it with the date. And after I show you all the next step in the documentation, and if you have questions or things like that, we can exchange about our workshop. So here, I just press on play. So if I press on play, I see, so I have to select still my admin division, and I have my date from and date to. So here, I can select the right one. So if, for example, I want our dataset is from January 2021 until now, quite something like that. Mm-hmm. So if I put, I think 01 2021 to 10, 21, a huge lot of range, and fire dataset. So for this one, I need to use the archive one because the other layer, it's only the 3 past months. You can click run, and you will select only the right dates. So I'm is finished. So close the window and go in my project, and here I have my new one with the new numbers. No, maybe this is not this one, the new one. Yeah, and we have the same range of number of fire by states. Yes. So it's where we stand. So if I go back on the documentation to explain the next step, even if we didn't do now. So we do the step 2, manage the date in our algorithm. But now to finish the first part to enrich the model, we will have to calculate density and export centroid to do some proportional symbology in our project. So as I said before, we want for each state of Brazil have a graduate color for density of fire, but also a proportional cycle for the number of fire to be able to judge between the number of fire and the density in our representation. So if I go back on the documentation here, to create the centroid, to do the proportional symbol, we will have just to create a new algorithm in our model, and which is named centroid. And so we have to rename it, manage, create the name, and that's all. And create the output to check. So the model will look like that. So with the new algorithm here, centroid admins, and the new output. After, we'll have to calculate the density. So in the documentation, we do it only for high fire, but we can do for nominal fire and low fire too, but we just extend here for the documentation. So to calculate the density, it's a bit complicated, as we need to pay attention of the projection of our layer. So you can continue. So yeah, we need to pay attention about the projection of our layers. So our layers need to be in units, to have a unit in meter. If we have it in degrees, we won't understand what is it. We cannot calculate the density with degrees unit. So we will have to reproject the layer. So we will use the algorithm reproject layer simply, and use the pseudo-Mercator projection. After that, we will have just to calculate a new field for fire density. So I put H in the field name to precise its high fire density. The type of field, it will be decimal, a real number. You can put a long length and long precision to be sure of all the number you need. And the expression will be the number of fire on the area of the state. So the expression in QGIS, the function to calculate area is $area. So basically, it will calculate all the density for each features of the administrative layer. So here is the state. So for each state, it will calculate the density. What you need to pay attention. So the model looks like that at the end. So we have this new algorithm, field calculator admin. So it's the density of fire in the admin layer. And you have this output. What you need to pay attention, it's when you density. So when QGIS calculates the $area, the area for each state, for each polygon, it will calculate in function the project properties of QGIS. So you will have to go in the project properties. So here, project properties, and here in the general settings, you have two kind of units to define, but here you need to define the units for area measurements in square kilometer if you want it's calculated in square kilometer or in square meter. If not, you will have like a difference of 1,000 something. That's all.
Yeah, maybe we know we're a bit late. Maybe is there any like last question before we do wrap up on the session? Any general question on the graphical modeler or anything? Do not hesitate to speak up or use the chat.
Before maybe the question, I can speak just quickly about the last part of enriched model, the part 2. It's exactly the same thing, but with a grid. With the model, we'll have to create a grid. So we had a new grid, so square by square on the area we need, and we will count points in the grid for high fire, nominal fire, and low fire, and we'll be able to show a graduated color between square of the grid and to represent the fire density. So you can have that also at the end of the model.
There is one question.
Yes.
To explain again the dependencies.
Dependencies. So we can explain from here maybe. So all the dependencies, it's like to run for example, here, this line, you see a dependencies between this algorithm and this one. It means before the computer start running this algorithm, it needs to have finished running this algorithm. So as we define the dependencies to finish this calculation before start this one, the computer, when it will run the model, it will run all algorithms in the right order. And in the model, it's like that. It's managed really here, dependencies, here. We select the right one. Is that clear? Okay.
If there is no other question, okay. Will the documentation remain available? Okay. So yeah, about that, I wanted to kind of close the session on that. So we know it was a bit dense. It's always hard to do a technical workshop, especially online with limited time, like 1 hour and a half. So here, the documentation will stay available. we hope that now you understand better the way it's working. Graphical Modeler, you can maybe try to continue with the documentation, or to try something else if you have any example on your case that you want to test with the modeler. If you are kind of lost, there is always tons of documentation, official documentation of QGIS, and you can also send us an email. I sent you an email last week, so you have my email normally. So do not hesitate. Just to do wrap up, maybe it's new for you, Graphical Modeler. To be honest, it's not used that much in project for now, because it's really sometimes specific. But it can be really interesting if you know that you're working on a stable data set. You want to always have the same kind of analysis. It's really efficient and can save some time. Another thing interesting with the Graphical Modeler is that I really believe that it can be a first introduction to scripting, because when you're on the Graphical Modeler, you can always export what you did as a Python script. So meaning that if you know you want to go a bit further than that, and you want to run a script on a server, something like that, it's really more advanced. But just for information, you can start from this export and maybe improve it, because you have many features in the Graphical Modeler, but it's still not as exhaustive as scripting with Python, for example. So especially if you want to automatize some processes, especially online with server, it's better to use Python script. But it's a start. You can export it as a script and make it run somewhere on the server, for example. It can be really, really useful. And it's still, as it's QGIS, as it's open source, it's always improving. So, for example, recently there were last year a crowd financement. I don't have the word. Anyway, some company, North Road, was gather some money to continue further development on the Graphical Modeler. So we know we'll have more feature coming because of that. So it's always really interesting to use this kind of tool and to see those evolve over the time. Any last ones?
Maybe one thing we haven't said so much is when you build your model, don't hesitate to save as your model. And it's mainly when it starts to be complex, sometimes you fucked up a bit your model, and it's good to be able to back on some version of your model. So here for the exercise, we do like a saving management example. So where we save our model, like for each step of our model. So the first one, and etc. And you can reopen your model in each version you have, to start again or to start differently, everything. But it's important to save if it's crash or something, to don't lose all your works, as you know. Not much. If no question, we will wrap up.
Yes, we're already late. Sorry for that. It's always hard to finish in time. Thank you, everyone. We hope that you enjoyed this kind of introduction, and that you will continue to enjoy the event online. And do not hesitate to reach us. As we said, we can also exchange with you. So have a good end of afternoon, and see you around, everyone.
Yes.
Bye bye.
Bye bye.